L.A. node, yada yada. All the major cities, Paris and Beijing, etc. And then you have a problem, say, in Sydney. And Sydney might not have a solution for this problem. Sorry, I got a cough. So Sydney might not have a solution for this problem, but because of the global instant communication system that we've got, the web that we're using, it can call out to Beijing or Paris or all the cities all at once and say, have you guys ever run into anything like this? And be able to get valid input from inferential data. Basically, yeah, we had a problem similar, and this is the computers talking to each other. This isn't really people. Eventually, people might have to get into the mix. But the first line of defense is, can the computers fix it themselves? Can they contact the other node systems, and do you know how to do it? So it's like a whole bunch of motherships, not one big mothership. You understand what I'm saying? Mm-hmm. And so they all talk to each other and see if they can figure it out. And then if the computer system can run the algorithms and come up with, say, you know what, I think a mixture between A, B, and F are actually the closest to what I have going on here. Let me implement this solution, A, and see if it works. And then do an analysis, maybe run a model demo, and then contact the subject matter experts for that particular problem via page or email or something and say, hello, this is your central computer system for the city of Sydney. We have a problem, and here it is, and I've already done inferential data analysis, and we've come up with a solution A, B, or C. I'd like to put together a contact team to get together on this date and work it out who is available. And then people would respond and say, I can do it. You get a team of 20 or so people, and they all go to this one location in this really fancy building in this office. It's going to be all clean and green and high-tech, and they're going to sit down and they're going to get all the analysis, all the data, and all the information, and then they're going to be able to arrive at the proper solution if the computer itself doesn't feel comfortable with doing it. And that'll be pre-programmed. The computer will know what is relevant to do on its own. It'll probably be like impact specific. If X problem impacts 1 million people, don't do it on your own. If X problem impacts 50,000 people, do some of it on your own and contact a discipline group. If it affects less than a certain number of people, just do it on your own and see if it works. And so maybe something to that effect. The lowest impact problems, small ding, could be done completely autonomously, maybe with reports sent out to subject matter experts saying, here's the problem, here's the solution that I did, I give 15 days to see if the problem rectifies itself, just to let you know. Kind of like that. And then the subject matter experts, and then they'll be in a database. It's just like submitting a resume to the central system and say, here's my education, here's what I know, here is my background. If any problem ever comes up with these particular disciplines, blah, 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 contact me. And everybody can put that in. And even an artist could do. This is where you were talking about credentialism earlier. This is where credentialism does kind of fall away, because say a person who's dominantly a sculptor, they just like to sculpt, but because they have this interest in, string theory, or something like that they also can, and they have an education on it, they have a background on it, some kind of formally background in, engineering or something, they can say, well, I'm dominantly an artist, but I do know a little bit about this particular subject I'm really, really keen on because I just enjoy it. So if you ever have a problem that comes up with that, let me know, and I can help. So that's where credentialism goes away, because now the system can find people based on exactly what they know and not just some vague degree.
Yeah.
Stuff like that. So that's how I think you combat the whole chaos theory system, is by having all these redundancies and backups built in, and the communication that goes around to help mitigate those. Can you completely stop a circuit board from frying? No. You're gonna have one-off anomalies. You're gonna have a beta particle from the sun get spit out, and it's gonna travel its several 100,000-mile journey at the speed of light, and it's gonna fly right through the atmosphere. It's gonna go right through the planet, and it's gonna hit that circuit just at the right time where your shit's gonna fall apart. And you'll be like, fuck. Well, that might happen, but you know what? That one circuit has 9 backups.
Ah, yeah.
So if it does go, fuck, then the next one just kicks in. Boop, okay, we're good. We lost about a millisecond of activity. When that died, we instantly switched over to the next thing in parallel.
But with the multiple levels of redundancy, they'd be able to compensate for that loss. They'll be able to, reanalyze the, say, for example, if it's managing some sort of transportation system or something.
Right. Or the power grid.
Yeah, or a power grid. They'd say, right, we lost a millisecond. It could even find out what happened in that millisecond, what is different, and and just carry on going as we are. Exactly,
and that's how you combat chaos theory. The thing about chaos theory is it does have validity. It does help with analysis. There's a lot that goes into it. It is scientifically valid. The way you combat that is with redundancy. So that's why that we were talking about the space shuttle going up. That's why the space shuttle has 3 onboard computer systems, not 1. Wow. There's a reason why.
Redundancy.
Redundancy. There's a reason why high-tech operations are, people say, why is that stuff so expensive? Why? Because they have 3 of everything. They have 3 of everything for a reason. And engineering and knowledge dictates that, Murphy's Law, if something can go wrong, it will go wrong. And so how do you combat that? That's like the layman's version of chaos theory. If something will go to shit, it will go to shit. And so the best way for you to is to have 2 or 3 versions of it running at the same time, because the statistical probability of all of them crashing at the exact same time, even though they are completely disconnected but running in parallel to service a particular function, is so astronomically small, even chaos theory scratches his head at that thing. So, it's not something that can't be overcome. So as far as I'm concerned, chaos theory has absolutely no bearing whatsoever on technical solutions and engineering practices, because we already account for that by building redundant systems.
Cool. Okay, so would you say that a resource-based economic model, would you say that that is a non-linear system?
I don't know. I would have to go through again and really let me look at non-linear system just one more time, because there's ways you twist definitions.
Yeah, because I think in the story of stuff, she describes our current model as a linear system, because it's linear from production, manufacturing, use, and waste. I think that's a definition of a linear system. But,
it's let me see. The problem is chaos theory is basically a lot of mathematical masturbation. It's very much a math-centric, playing with numbers kind of theory. It does have some real-life functions, but our industrial process is quite linear. But the RBE isn't really getting away from that so much as it's separating it out. It's decentralizing that linear system. So right now the linear system is quite centralized. You have a handful of companies using the system to create a handful of products in specific locations and then having to distribute it out around the world, which is very efficient. Well, what the resource-based economy is doing is all of these nodes are going to be their own manufacturing facilities for that particular region.
Yeah.
So but the actual process is still linear. You still have to extract resources. You still have to refine them. You still have to make whatever you're going to make. Now, you're going to try to do it more ecologically sound and all that other stuff, yes, but it's still a linear flow. You're just having about, 1,000 of them around the planet all going on at the same time to service the local needs of the region that they're required to service. Instead of having it centralized, it's decentralized linear production with ecological awareness in mind. So let me read this really quick.
Okay.
In mathematics, a nonlinear system is a system which is not linear. No shit. Well, that's basically what I just said. Multiple variables, multiple nodes. So it's a whole bunch of linear systems working together. Now, are they directly related to each other? No. Because they're servicing their own specific needs for their particular region, whatever their population needs. They might have more of one resource than somebody else, so they just might have a different flow than somewhere else. But so if you were to look at the planet as a whole, it's very much a nonlinear system. But if you were to break it down, it's composed of a whole bunch of little linear systems.
Yeah. Well,
there are a lot of scientific studies and things. Okay, robotics for one. There's a lot of nonlinear stuff in robotics if you're looking at self-correcting systems. You know, you take input A and input B, and then the robot does a particular task, but then a new unknown variable comes in. Well, now it's nonlinear because you have a new input. So the robot needs to, on the fly, make an adjustment to facilitate that new input using A and B. But there's algorithms that cover that. There are ways to handle that. We do that now. And so a lot of our obviously one of the key chaos theory things is weather, being able to predict and track the weather. Well, we've gotten it down to where within a couple of days we really know what's going on. We've taken a chaos theory, that nobody ever knew what was going on and got it down to relative decent accuracy within 2 to 3 days of the event. And so, and we also know causes and effects. We know what makes a hurricane. A hurricane is a very chaotic event. And it takes a lot of different variables happening at certain times to create that thing. But we also know where those variables come from. We know that it starts over here by Africa. I'm talking about the East Coast side of things. It starts over by Africa. The wind flow plus the current of the ocean, and if a certain amount of wind shear does this at a certain particular altitude, it's going to create a twist, and when it starts to do that, then it can turn into a hurricane. Now, can we predict exactly, can we track this molecule that's up in France and follow it all the way down, the whole butterfly effect crap? Follow it all the way down and say, 2 weeks in advance, that molecule is going to cause a hurricane. No, we can't do that.
No.
It's chaotic. Anything could come at any moment and knock that particle out of the way and completely change the dynamics of the whole scenario. But the resource-based economy doesn't really navigate on those principles. The resource-based economy is pretty simple. Food, water, shelter, clothing, all the basic needs for life created in abundance by technical systems. We already know how to use technical systems. We use them all the time. We're just not using them properly. So the RBE isn't inventing anything new. All it's doing is taking what already exists and using it in a better way. The Internet already exists, global communication, the robotics, all the capabilities are already here. So if chaos theory was to have a detrimental effect to the resource-based economy, it would have a detrimental effect to all the systems that exist now. But we don't see that. All the systems work fine. They're just not being used properly, but they work.
Cool. Okay. Well, I'll go on to some of the other things he had to say. He said, if you propose to have a computer allocating resources, that computer must have an algorithm for doing so. I claim that optimal allocation of resources is a problem that involves a great number of non-linear interactions, and thus there is no analytical solution that can use an algorithm to obtain.
In a way, he's right, and I think I know what he's talking about. But like, for example, let's go with the food bit. And you have a city of 1 million people. However, it's not people, is it? You got people leaving, going, coming, back and forth. You don't know when. You don't know why. It's very chaotic. You have no idea what your true population is at that moment. The only way to do that, and I do not advocate this at all, the only way to know that is to literally bug every person, with a chip or something so that you know exactly how many people are in a given area by monitoring them, which is stupid. I am in no way in favor of that at all.
Nah,
So what do you use? You use statistical probability plus a % over. And that's what you use to determine how much food to make. You know that the average population of your city at any given time is X number of people. You factor in X number of people as your baseline plus 15%, and that's how much you make. Because you know over time that you've never gone over that amount, and you've never gone under that amount.
Yeah.
If you have a little bit of waste, so what? In that particular case, it's food. When it comes to actual products are made on demand. They're no longer going to be made, we're going to make 1 million of these and hope we sell them and stick them in a warehouse. Not going to work that way. Not with the processing technologies that we have today. If somebody wants a computer, for example, they program in what they want, they hit the send button,